Hi, everyone. So before we get started, I know some of you have started already, but we want to get a feel of, I guess, who's with us today. So we have these different straw polls here set up. If you would like to, go there and tell us a bit about yourself. Polls are all anonymous. Thank you. And then after this, maybe a couple minutes more, we'll actually get started with the tutorial.
Did you apologize for the internet yet?
No, it's not working.
Well, it's doing what it did yesterday.
Really?
Yeah. So just a note, if your internet is not working correctly, that seems to be the norm here. So unfortunately, a lot of our stuff is based on doing things online, because it's like some test automation and stuff you'll be doing that requires you to actually use the internet. So we'll have to just kind of bear with that. But basically, if you connect and then wait, it should allow you to connect eventually. And then if you try to load a page and it fails, just try again. It's pretty terrible, but we have to get through it.
Just a suggestion. I'm trying to enter it, and it says that you already voted on this.
Oh, that's terrible.
And,
I wonder if it's doing it. It's probably like IP based or something.
or the browser. I'll check with another browser.
Okay, it's not actually too important. So we could actually, instead of maybe doing the straw poll, we could just do a show of hands for this, and then we don't actually have to wait for the internet to load. So I just want to get a feeling for like where everybody is at and kind of what you're hoping to get out of this. So the first question is, what's your role? So who here is a developer primarily? Cool, most people. How about like ops role? A couple people. Is anyone a manager? Cool. How about QA? Student? A couple people. Hobbyist? Is there anyone that didn't, like any other groups, people? Okay, cool, it's about everyone. So we've got mostly developers, but a few other people. Who has no idea what a test is? And you can admit it, it's totally cool. Okay, a couple people. We'll be going over that. Who thinks testing is not the job for developers? Nobody, perfect. That would be probably a very unrewarding tutorial for you then. Who has written a test before? Okay, cool, so most people have written a test. Who writes tests on a regular basis? A few people. Okay, cool, so if you're already familiar with testing, you might find some of the content a little bit slow, but we've tried to add in some kind of like bonus activities, so if you get ahead, there'll be a bit more to do. You can also just go ahead in the steps, like you could just go on to the next step, or start on the last two steps, like 7 and 8, we might not get to today, depending on how quickly we get through the material, so you could just take a look at those if you run out of stuff to do. Python experience-wise, who is totally new to Python, like just started using it recently? A couple people. Who has been using it for like less than a year? How about like 3 years or more? Okay, cool, so a lot of people, but we've got some beginners, so that's cool. Should be fine. All right, so I think we can get started then. Oh, we also have this thing is supposed to be going on our heads, but there are two of us, and we kind of go back and forth, so we're just going to pass it back and forth. All right. So without further ado, I'll introduce myself? Okay, yes. That's fine. All right. So my name is Christie. I'm a senior software developer at a company called Demonware, which we'll be talking about in a couple minutes. I'm also a team lead of the test tools team, so I do a lot of test-related stuff. And this is Michael.
Hello. I'm also a developer at Demonware, but I mainly do tools and automation.
Cool. So, oh yeah, Demonware.
So if you'll notice the cat at the bottom left, it'll be alternating depending on who's talking. So, if in case we mess up, please feel free to correct us. Okay, so obligatory plug, I guess. We're from Demonware. We work in the video game industry. We work on games like Call of Duty, Skylanders, like those sorts of titles for Activision. We do the back-end online services, and that's it. On to testing.
So since the company did pay for us to come here, we felt like we should probably mention them at some point. Okay, so the schedule for today, we're basically going to be going between, we have some kind of like learning content. We'll explain some concepts to you, explain some things with Pytest, and then we'll go from that to an exercise, and we'll be going back and forth between the explanation and the exercise as the day goes on. The first bit is going to be making sure that everybody's environments are set up, which typically takes the longest, so that might be the most boring portion, especially if you've already gotten it working. So during that time, looking ahead is probably your friend, but we'll just kind of all get through that, especially with the internet. It's probably going to be interesting, but once we get past that, it should go fairly smoothly. So from there, we're going to go into what testing is, what unit tests are. We're going to write some tests. Then we're going to talk a little bit about test automation, and assuming that the internet behaves, we're going to show you how you can run some of the tests that you've written through some test automation. And then we'll talk about some more advanced techniques, and we're going to be using Pytest through the whole thing. Who's used Pytest before? A couple people, cool. So hopefully you will learn to love it as much as we do. And then if we have time, we'll do some questions and answers, but just feel free to ask us throughout the tutorial.
I guess we've gone over this already. Okay, well, I guess in case you wanted to see a bit, like in more detail, what we'll be covering. So unit tests, how Pytest works roughly, in case you don't already have a good idea of that. We'll also talk about some ways to measure the quality of your test code, I guess, as well as your application code too. And the more advanced testing features are things like mocking or using fixtures and so on. And also, one fun thing at the end will be seeing how to refactor your code to maximize how easy it is to test it.
Okay, so the first question, what is a test? So a few people raised their hands when I said who doesn't know what a test is. So it's kind of, we actually had some trouble finding a definition for what a test is. It seems kind of like one of those things that everyone just accepts, that everyone knows. But I think the best definition is just that a test is something that describes how you intended your software to work, and you can run it to verify that it actually does the thing that you expected it to do. So as far as why you would test, there's kind of some misconceptions around this. The biggest reason to test is just to increase your confidence that your code does what you planned, what you wanted it to do. It turns out that some studies, which I cannot source here because I could not find the source, so you may not want to trust this information, but some studies show that you can't ever really be 100% confident in your code, and it's true, you're never really going to find all the bugs. So no matter how hard you try, there's always going to be something there that you didn't think of. But if you do proper testing or you do enough testing, you can be about 60% confident. So you can be confident that you got like 60% of the problems. And it turns out if you want to get that number higher to like about 80%, the way to do it is with manual testing. So like exploratory testing, having people actually go in and try things out. That's the only way to get higher than that. But the point is that you're never going to be 100% sure, so you shouldn't expect your tests to actually give you 100% confidence, because all they can do is just make you feel a bit better. So we're going to talk a bit now about some different types of tests. Unit tests are what we're going to focus on in this tutorial, but there are some other types that are pretty important. And the reason that we have these different types is because if you want to write a test for every single test case that your system has and you want to test it from the outside, it's going to take a really long time. You're going to write a lot of code. The tests are going to be hard to maintain. They're going to be slow, and they're going to be hard to write.
Okay, so we have 4 types of tests generally, starting with unit tests. So these are like the tests that test the smallest components or units of your system, right? So we have some nice pictures here to sort of help illustrate this. So the top one, unit test, tests the individual features of this cat, right? So for example, the nose in isolation. And our goal of these is to get as much coverage as possible, right? So we exercise the small unit as much as we can because it's nice and small and isolated, So we can do that, and we want them to run as fast as possible. The next level of tests are like the integration tests, where we try and combine our different units together and test them, right, to make sure that they work properly with each other. So in this case, we have like the whole face, right? So making sure all the face units or components work together. Third, I guess the next level up above that is system tests, where we try and test the whole system together. So in most cases, this will be from like your end user's perspective, right? So like in our case, we do online services, so we will our system test would be testing from like the gamer's perspective, right, all the way to us and back to them. Finally, we have acceptance tests. These aren't really talked about that much, I don't think, usually. These are more like tests which are based on your actual business requirements, right? So like, I want my users to be able to do something. And so these should test that from like a high level. So I guess I've sort of talked about this already, but we can also see here how everything just fits together. You know, the different things are colored. And then using this entire suite of tests, we're able to get enough coverage to be confident that our software works. Okay, so this is where we're going to pause the talking and start working on the hands-on stuff. So in this first step, we'll be hopefully getting everyone set up with a test environment. So should I just try and open this in case the internet's not working? Yeah. So I'll open this up here. The main like summary of this is you want to have a GitHub account, you want to have pip and virtualenv or PyCharm, and you want to try running our test suite. And the instructions for this are all in that link over there on our GitHub repo, but I'll also try and bring it up here for everyone to see in case you don't have that.
So I guess one question I'm wondering is, you talk about like having 100% confidence that your code will work, but it seems that one part that's missing is I've got tests to try to test the cases I think that how the program ought to behave. But don't you have to sort of sit down and just say, well, how should my program behave? Or don't you need to sort of do that? Like, in order to talk about you're being bug-free, you might have to say, well, what is my program supposed to be doing? Do I need to write that out? This is how I expect it to behave. Or the tests are sort of telling you, well, the tests tell you what it's supposed to be doing. I'm trying to get to understand what is correct behavior, and when do you try to determine, or how do you determine?
So I'm going to try to repeat your question for the recording, but let me know if it's not covering it. So I think you're asking about the test just being a reflection of what you think that the code should do, but maybe you have to spend some more time reflecting on it.
Just say this is my expected behavior and write it out. Or?
I guess the tests usually are like a formal representation of what the expected behavior is. But I'm not sure if this is what you're getting at, but I think you're right in that they are limited to only what you think the program should do. Right. Is that kind of what you're getting at?
Yeah, because if you're saying, well, there's 40% could be bugs, well, but bugs in what sense? Maybe I didn't think about this test case. I don't know what it should be doing. And then you look at it and say, oh, it's not doing what I thought it should be doing, but I didn't really specify what it should be doing.
Yeah.
It seems wrong now.
Yeah, so you're saying like that other 40% that you're not sure about, or that it might be defects, like what is that? So it can be like bugs in terms of like things you think about where it's like you didn't account for some particular like edge case or something, but it also can be defects like you're saying in that it might just never have done the thing that the customer wanted it to do. So there's kind of like a wide variety of things included in that. But I guess the thing is, as a developer, if you're writing these tests, all you can really do is write tests for what you think that the software is going to do. And things like test-driven development will help you like think about that kind of stuff in advance, which can be really useful. But like if you want to go beyond that, then I think you're kind of getting into the territory of like requirements gathering and also like manual QA, that kind of thing. Like those kinds of things are still pretty important if you actually want to be like as bug-free as you possibly can be. But you never will get everything. There's always going to be something that you miss. So how many people need to set up their GitHub account still? It's totally okay to admit it if you're one of those people, because we'll come by and help. Okay, cool.
Sorry, but also, who has gotten to the end of this first step already from before we started? Okay, cool, great. So as Christie mentioned, we'd advise that you guys, I guess, read ahead a little bit. Hopefully, we'll try and get everyone up and running like relatively quickly, but just in case. So if anyone has any issues, just please raise your hand or yeah. Slides. They are like these slides, not those slides. These slides.
basically replacing stuff with Python interpreters, PyCharm, and file settings. Then you go down to your project. Right there, project intro. If you've already set up the virtual environment, okay, well, we need to set that up first. Yeah, so go into that, then we'll build the virtual environment. And then we'll add it to the PyCharm.
You can also do like within PyCharm directly.
Yeah, the problem with that is
So it'll take like after the
virtual environment doesn't know about it.
continue to form.
Working PyCharm.
Yes,
stuff.
yes.
So if you set it up.
Yeah, so if you're looking for something to do, the last section actually is actually stressing refactoring for testability. I'm not sure if we'll get to it.
Oh, okay. So what do we do if we're, don't just wait for?
Yeah, wait, we're take a look at some of the, like the
So it looks like
step
before
2,
this-
or you look at the step 8 or anything.
So I think the problem here was.
Okay, so this is like a test format, actually. You're writing a lot of unit tests, it makes sense to have some kind of name standard you agree with.
Sure.
So what this particular one is test, or the name of the thing you're testing, this is the precondition. And then this is like what you expect from that to happen. So
Right.
it's saying like, there's kind of intention here, so you can see it's kind of.
I'm trying to, well, that's what I'm trying to figure out, is when you're, so if I put it in this really great, ask me how to do down, could you copy the first? Good, now it's a good discussion. Okay. What is the key debugging?
But the answer is he's not sure. Sometimes you
Not sure, I'm just doing job, right?
not sure if Pytest does it, but sometimes.
I guess running debugger where it's at breakpoint and it'll inspect. PyCharm probably can do those things.
Python does it, Python does it well. I use in Windows, I use yes, Python tools,
Oh, okay.
which does it incredibly well. And then you got the inbuilt Python. That means if you're when something's going on and you want, but there, that has no UI, this is plain, it's like GUI. Yes.
So we've done a little bit of recent virtual environment. So it's much different in that sense, because I guess it's, yeah, it's very command oriented. Set a breakpoint, run, and then
First,
show
if you don't
have
have
it.
it.
Rather than just like more you click.
Exactly, so if you don't have like UI, you have PDB and then.
Okay, so now what we need to do is set up your SSH.
Okay, and all these are commanded, are, I mean, in the middle here, version more graphical.
Yeah, PDBS, Python, all these it's just like a proper debugger.
Yeah.
I'm sorry, so it's,
The one that's I've heard of,
Yeah.
things like it will be the big,
Yeah.
it's GDB like.
I like this.
Yeah, and this is.
This has a UI.
Yeah, that's why I was like, yeah, maybe I'll say
So what's all for here? No,
But it's really good. And I'm a big fan. So in Windows, I'm a big fan of.
that's one that I'm like,
Try it.
But I'm losing my
Hey everyone. So just a show of hands, who here has not made it to the end of this first setup environment step? Okay. Oh.
Okay, are you stuck at the moment or like still working? Would you say that you're stuck or like able to still work through, working through? Okay, we'll come over, I will do like maybe 5 more minutes and then we'll keep going.
Well, we're thinking that I was working on a group. What happened is that when I first got hired as an experiment, my second got hired as an right away they kicked out. And I was involved in a project. I was working for so we were working in a bunch of other areas. First for a while, MIT for a while, so it's Florida State for a while. A lot of those labs for a while. I did University of Washington, Seattle. What you discover, by the way, is that most of these users cannot even discover what they do. People just decide, okay, we're going to go somewhere else. Now we can do your education is too good for us, actually. Actually, work at the same place, just graduated. Okay, so you know, we were trying to Agile, where we failed primarily was that we're going to cloud efficacy, but it's so exciting. But it also led to discussions like just feedback, talking about things and not getting things done. So that was eventually after 7 years. Their whole idea was to say, forget about the collaboration. We're just going to build it.
Know about master. Very strange.
Okay.
All right, who's next?
Oh, this is me. Okay.
Straight into.
Sure.
Okay.
Okay, hi everyone. We're going to move on with the tutorial. Great. So hopefully now you've all a chance to run your tests. You know, you see that they should all pass, but the coverage is very low. So this next session, we're sort of going to first go over, I guess, different types of coverage that you might want to aim for, and then afterwards we'll actually work towards improving the coverage of our test suite. Cool. So in general, there are 3 different types of coverage. There's statement coverage, decision coverage, and condition coverage. So in the first case, statement coverage is just, was this line executed, right? And in most cases, just by running, like if you call your function in your application, right, you might get full statement coverage just because it executed all the lines. But that doesn't mean that all the cases are covered, which is where the other types of coverage come in. So for the next one, was every code path executed, right? So if you have lots of conditionals in your application, you want to make sure you exercise all of them to make sure that each of the cases is covered by, well, some sort of test. And then finally this is sort of a subset of the previous one, where you actually want to make sure that all the possible ways you could reach each of your code paths should be exercised. So in this example here, we have an if with two things that are being OR together. So because with OR, if either of them is true, the entire thing is true, you want to make sure that you try all the ways that either of them could be true to get full coverage.
So one statement about unit tests that we'd like to make is that sometimes people get into kind of like wars about hating unit tests or really loving unit tests. In our opinion, we kind of feel like it's not really something that to hate or love. It's just something you kind of have to accept. Sort of the same way that you brush your teeth every day or so. You may not actually see a lot of benefit from it because you don't get any cavities. And you're like, maybe if I stop brushing my teeth, then I also wouldn't get any cavities. You don't really know. So you could be writing unit tests faithfully every day and never catch a single bug. But if you didn't do it, then you might, you basically don't know. It's just kind of one of those maintenance things that you have to do. It's like one of the bare minimum requirements for quality code over time. So another thing that we'd like to talk about, kind of around misconceptions around unit testing, is what they're good for. So a lot of people view them as being good for finding bugs, and if they're not finding any bugs, they think they're not getting any value from them. What we find them really useful for is finding bugs while you're developing, so having tests alongside your code and running them can help you find problems as you're working. They're also great as a design tool. We don't really get into it too much in this tutorial, unfortunately, but test-driven development is pretty powerful. And if you use test-driven development, then you have to think about the design of the code before you write it because you have to write a test for it, and that can be really powerful. They also make your code more maintainable. The very last section of this tutorial, if we get to it, talks about refactoring for unit testability. If you write your code in a way where it can be unit tested, then the code itself is actually better. It also documents your intentions, and these tests are extremely fast. So these are the things that we really like about unit tests. Things that they're not great for are finding bugs. As we said, they document exactly what you thought your code should do. So if you miss something, then you're not going to catch that bug. You can only catch the bugs that you're aware of. They also don't necessarily indicate that your application is functioning correctly. This kind of illustrates you could have unit tests for your application, but if you don't actually test all of those units together, then maybe all of your unit tests pass, but maybe your application doesn't work at all. They're also not great for testing something called glue code, particularly if you're doing a lot of ops work or any kind of automation. You might be writing a lot of code that glues together a lot of other components. If you write unit tests for that, the tests can be kind of just like a messy soup of mock objects that are kind of meaningless and hard to maintain. Unit tests are not really very well suited for that kind of testing. They also aren't great for testing every possible permutation. That's just kind of like an onerous thing that we wouldn't advise that you do. So in general, if you take away nothing else from this tutorial, our view is that unit tests are not primarily for finding bugs, but the real benefit is in writing clean and maintainable code and feeling confident that it did the thing that you intended it to do.
Okay, so I guess I briefly talked about coverage. Next, we're going to go over how you might start thinking of how to generate your test cases. So as mentioned earlier, these are usually driven by, I guess, what your function or what your application is meant to do, right? Like the actual use cases. And we're sort of going to go over a couple examples, and then we'll dive right into writing tests. So how do we test this? So this is a function which returns true if the given input, a sequence, is a palindrome. So does anyone have any ideas of what a good test case for this might be? Like what input would you give it and what output would you expect? Sorry, I also define what a palindrome is. I realize now the doc string is sort of like self-referential. So a sequence is a palindrome if it is the same in the forward order and the reverse order, right? The same in both directions. Yes, so does anyone have any ideas about what a good test case is? Input and output. Yes?
Input a known palindrome, like the name Bob, and then output, you expect the output to be true.
Awesome. So the answer was Bob, the string Bob, and then you expect true as the output. Great. What other kinds of test cases are there? Sure. Random types. Okay. For example. Awesome. Cool. Yeah. But testing for unforeseen use cases, for sure. Yes. Okay. Yeah. Awesome. Yeah. It's very good to test the cases where it was successful, but it was not like the positive case, if you know what I mean. Great.
Say sequence, but do you mean specifically string or any sequence?
Yes, you caught on to that. So the yeah, exactly. So just to repeat that, so far we've talked about strings and I guess just random types. But the good comment was that this actually will work with any type of sequence, right? So list, set, tuple, your own custom thing which implements the same interface. So those are things to also be aware of when you're generating your test cases, right? Other cases where it'll work, but at the same time, I think you mostly care about the cases where you have defined your function like to actually work, right? It is defined. So if in like your application you only work with strings, it's probably sufficient just to only test with strings, you know? And if someone gives you a non-string, it's sort of like something might happen, I don't know, you know? Yeah, so we sort of cover this input, which is a palindrome, which is not a palindrome, right? I briefly alluded to this just now, so trusting your input, right? So we talked about random types, and what we didn't talk about was if your input's really big. So for example, a string with like 1 million characters, right? I guess at some point you want to trust the input you're getting to the function. So you don't necessarily have to account for all of these different edge cases, unless this function in particular is like customer facing, like you're giving input directly from your end user, like with hopefully like you would sanitize it. But you know, if it isn't like the front, like the edge of your system, you definitely want to think about these things. But for internal stuff, which is generally what you're testing with unit tests, you don't really have to worry about that too much because you trust all of your developers. Great, so second example, this is a function that returns true if the given input year is a leap year. While I was coming up with this, well, not coming up with it, looking at Wikipedia for this, I sort of remembered back to, I think it was 2006 when the Microsoft Zune bug happened, if any of you remember that one. They had a bug in there, a thing I think which returns whether, what is it, was it days since? Okay, whatever, there's this bug which caused an infinite loop and it caused the Zunes all to pretty much just crash, well not really crash. The solution was drain your battery and wait for it to die and restart it and it start working again because there was an infinite loop caused by a bug in, I believe, was their leap year code. This does not have that bug, thankfully.
So like in the last case and even in this case, because Python will let you sort of pass in any type, is your general philosophy to sort of say, well, I am expecting an integer here, but I'm not, do I need to write it out or should I try to prevent other types from being used and just, you know, throw an exception or something like that, or what's the general philosophy? Just say, just test the things for the right types and don't worry about anything else or something else.
Yep. So the comment was about what we talked about earlier about trust and whether you trust all the inputs. So I guess to reiterate the point, yes, in Python you can do whatever you want, which is what's great about it, of course. So as I mentioned, for things which are more internal, so like this is more like an internal function, for example, right? You might have some in your application that only your developers are using, and you should trust your developers to know, you know, when not to do things. If it were like, suppose like an HTTP API, right? This is supposed as a public API that people can hit, you probably want to make sure that they're not passing in like things which aren't defined for this function, right? Like a string, for example, just because you want to improve their experience, and I guess you want to try and fail fast at that point too.
Just to add to that, I guess it's all about establishing trust boundaries within your system, because the thing is, yeah, it's also about like writing code defensively or not defensively. Like, so if we wrote this and we wanted to guard against every possible type of input we might get that's incorrect, we could do that. So like assertions are a great way to do that. We could assert that the year is an integer, for example, when it comes in, and that would be fine. But that makes the code, it takes longer to write the code, you have to write more test cases for it. So you basically just have to decide where you're going to establish those boundaries, and you have to have trust that at that boundary, the input has been sanitized and all the input sanitization has been tested correctly. So basically you're just deciding where you want to have that defensive layer. So you could do it all the way through your entire system, but that would probably be very expensive for you to do.
Is there a way to kind of specify, I want this to be at this trust level, like internal, okay, keep it low?
Is there a way to specify that? I don't really know of a standardized way to do it. I guess it's just about sort of like the layers that you put in your system.
Yeah, it's all about the internal process, since Python will not enforce any of this. And even if it did, you can probably get around it. Like, I think a while back, someone tried to write like a Python sandbox inside Python, but that doesn't work. You can just break out of it pretty easily. Okay, so again, with this question, who can think of a good test case for this? Input and output. Okay, great. So yeah, it just so happens that I think 2016 is also a leap year, so perfect. We can use that. And that should return true, right? Great. I guess one thing to also mention, I won't draw this out too much, is that you want to try to exercise each of these cases, right? So maybe not just is a leap year and not a leap year, but also is a leap year under like the first condition where it's true, and also the last condition, and also for the inverse as well. So I had some of these here. I just Googled for these just to make sure I did make a fool of myself here, given that no actual leap years. Cool.
All right, so now we're going to start talking a bit about Pytest. So if you're familiar with unit testing in Python at all, you might have already encountered the unit test module inside of Python. So that ships with the standard library, and it's great. You can do most of the things that we're going to talk about today with that module. The main difference is that there's a lot of extra stuff included in Pytest that can be quite powerful when you're writing a lot of tests. If you've written a lot of tests with the unit test module, you'll find over time that you write a lot of boilerplate. There's a lot of stuff you have to kind of copy and paste. You end up trying to do clever things like having inheritance, where you have like a base class that you're inheriting from for all of your tests that does some like standard setup, that kind of thing. With Pytest, that kind of thing is made very easy for you. Particularly fixtures are a big part of Pytest, which we'll talk about a bit, but they're super powerful and they can make your test code way clearer. It is, of course, also very magical, and any magic can be confusing for the maintainers of the code, but as long as you try not to use too much magic, it's actually pretty powerful. Also, the assertion syntax is a lot cleaner, so like the self.assert equal, basically you have to, with the unit test library, you have to inherit from a base class and then call these assertions that are included in that class. With Pytest module, you just use the bare assert. So it actually ends up being really clean. And the output that Pytest gives you in the case where it fails is like pretty good for debugging, like usually has all of the information that you need. It was a very hard sell for me to start using Pytest because I thought, why not use unit test? It comes with Python, and honestly, just try it out. Like once you start using it, it's really hard to believe that you're ever using the other one. So just some how-tos. So if you wanted to use this for your own project, you can install Pytest with pip. This isn't something you have to do right now because you would have done that with setting up the test dependencies already. So you can install Pytest with pip. Writing the test is just a matter of using assertions wherever you want to assert something. And then when you run it, you get output like that. And you get like a really nice stack trace when it fails. So the way that Pytest finds tests is it looks for any functions that start with test underscore. So if you just start your test name with that, it will run it as a test, and you just use assertion. This is an example of some things you can compare, and you get some helpful error messages if it is wrong.
Yeah, sorry, one thing to note here too is that we're using like many different types of comparisons here in our asserts, right? For regular unit tests, you would have like things like assert equal, assert dictionary equal, assert true, etc. And this, you just, however you would normally do it in Python, you just do it and you slap an assert in front of it and it checks whether it's true. Great, so I promise we'll get to writing tests really soon. Sure.
Yeah, it's just related to using Pytest with Django. Normally when you have Django, it comes with its own version of unit test. Can you use it, or do you have to plug something into it?
So the question was, for Django, is it possible to use Pytest? because Django does ship with its own unit tests compatible stuff by default. So great question. We'll actually come to sort of that area of things later, like Pytest plugins. But for now, maybe we can chat about this afterwards, if that's okay. Sweet. Yeah, but there probably is a plugin for this. Great. So before we actually write our unit tests, we're going to go over like the general structure that you might normally follow. So in this example here, we have the unit under test. I've been saying function and unit sort of interchangeably, since that's sort of functions are like the base building blocks of your application, right? And that's your unit, the smallest thing. So here we have a function which reverses a sequence. And then below that, we have two unit tests. So in general, for each of the unit tests, what you want to do is do some setup. So for example, you have some complicated thing you're testing. You want to get it into a certain state where you can actually test the thing you want to test. You do that setup first. You do some number of assertions to prove to yourself that it actually it works, the thing you're testing. No, sorry, I missed a step where you actually call the thing you're trying to test. That was number 2. So setup, invoke the thing, and then assert that the thing was run correctly. Right, so the assertion thing, the verification step rather, is more like you can test the internal state of the thing you're testing or test the output. In our case, we've been dealing with fairly fairly pure functions. So there's no state side effects. But in the real world, we have big classes and stuff, and you'll have to sort of dive deep into it sometimes to be able to prove to yourself and to other developers that what you were testing actually worked. Great, so one thing I'll mention briefly too is that in our test setup, we do enforce PEP8 as the standard. So for those of you not familiar with PEP8, it's a coding standard. It talks about things like line length or like spacing within your Python modules. And we'd recommend using it or some other coding standard. I guess there will never be one coding standard which really fits all companies, all applications, all projects. So pick the one that's best for you, but in our case, PEP8. This might come up when you start actually writing tests during the tutorial, because your test, Pytest will throw an error if your code does not meet PEP8. If that happens, don't panic. If you don't know what to do, call us over, we'll give you a hand. And now to the next step. So we're actually going to write a test this time. So if you would open up step 2, we'll be writing tests for our cat math module. And again, if you have any questions, please raise your hand and we'll try and get to everyone.
And I think we're about 15 minutes for a break. So if that is still true, we'll probably do this and then take a break after that.
of our modules, we have like a test underscore the same module and a test folder.
Okay.
So we certainly mix like the same structure of like your overall, your application.
Okay.
Just so it's easy to find, I guess, which test is associated with what. There's no like back way of doing it.
So it's a very common way to do it?
Yeah.
Okay, so your application will have some folder name, and then parallel to that, create a test folder, and then I guess if you use subfolders, then maybe you would also mimic that structure as well.
For sure, yeah. Yeah, you can definitely nest it as much as you'd like to. Like,
Okay.
whatever, like, clean separation.
Great.
Someone has a pull request up already. The parameterization. Yeah, I'm trying to choose the correct tone.
So this install, it's installed. It's already, it's part of the process.
It's part of the script install. So when you set up, the one of the steps will. This thing, the Python set up it maintenance download.
Oh, for sure, yeah. Like, you figure out what conditions.
As long as you have activated it and then did that, it installs it. So the way Python is part of global. One thing to install is that we just go, you have one place in the application.
Yeah, and like, it's like you had sort of hinted by the
But then
name
you
test
have
to,
packages that
I
you
guess, test
have.
underscore the thing for testing, and then sort of
And you don't want to
general
you have to put your
the
name
condition that we're testing. So yeah.
global.
So the first bit, like test
So what you
underscore, and
do
then
is
that's sort of like the
mini
semantic
version
thing
of
we're testing, right?
put
So in your case, you
so
decide
that
to
you
use like
install
0.5 and
with
so
that
on.
project. And then you can, if you want to distribute it back to somebody else, you can say, hey, what are the companies that are including out of this project?
Yeah.
And that's usually set up using the requirements that you
Okay. So I guess two parts. So
which is empty right now, but
those
this is the
line
requirements
methods
that
are
PhD
lines which we're not
gets
executing
populated, like you can populate it
inside chat
stuff that you need
So I guess like one of
what
those
kind of
So is there a way to tell, like, who's in an environment?
Oh no, this is before you.
yes, you can do it.
And then the number, so that the percent coverage is the statement coverage. So.
No, sorry.
Yeah, so actually, if you go back to the output of Pytest, so we have the number of statements in each one, and the number of ones that work for this. Like here, 1111 with 0% coverage.
So there's only one package that is not
complicated thing.
it's called Academy. I believe
But it's just a
Pytest.
experiment on Pytest that ships with statement coverage.
You don't need to install Pytest. It comes with
So skip this grab check. No, so like cap A check is like
oh
test,
no. So
but there's nothing.
you have this thing called test requirements and notice.
Oh, okay.
Then this and when you install cat in a box, it installs all
What is it? Oh, the pen. Sure. Yes, so we have to configure it to switch left. So inside the repo, I think there's like a setup.cpu file or something. And in there we set the
I do everything like in one folder.
So,
So it's like,
so each file is in Python is called module.
okay.
A folder that has is called the
Yeah, yeah, I'll,
this one is called
yeah, perhaps one of those, right?
Contains an underscore.
So it's a file,
Okay.
and that basically tells Python that this is a file. This folder has a bunch of Python files. So that's how you nest folders and Python knows how to go into the nested folders
Okay.
because it looks at them as files. But if you don't have a folder that is not like that, it doesn't go anything, it doesn't figure it out.
Oh.
So cat math is a module.
Yeah.
Cat in a box is a package. You might want to see a little bit of the package. So if you ls cat in a box, you'll see an underscore and never do that.
Oh.
So cat in a box is package, and cat math is a module.
Let's see, cat in a box is a package because it contains
The folder with a
okay, but then
and then so you look at your test on top.
yeah.
This was comment actually.
Oh,
So you have to go to the test. So in order to invoke it, what you do that by example code. So you did import it, you moved the comment outside. So what it does is basically saying from this cat in a box package,
Yeah.
import this logic college.
Okay.
So your cat cat years is years
Uh-huh.
is a function inside a module.
Okay.
And the way you reference it is always package dot module dot function or package dot module dot class.
Okay.
But if you run this import stuff, so if you just say, let's say you import only cat in a box, right?
Yeah.
So you import the package, then you say cat in a box dot cat dot whatever function you want.
I see.
But if you do cat in a box,
Well, I think it's really quite good.
I just want to know better way to write it.
Okay.
I know Python, but I've never really so so now you have this variable now exists. So now you can remove this part of it. We no longer need it. We know what cat math is. And you cat math dot. So it doesn't go look at it directly and say, right, this function is okay. You need to give it some structure for it to find it as a function.
But I'm gonna, so one thing, I'm gonna test I didn't know where cat in the box is.
So
I'm not in cat, I'm underneath one level, right?
so you're running the test using setup.
Oh, that's it.
And that's it. I have a folder that contains both cat and
Oh,
box
okay.
and test. And right, if it has an input UI, Python is understand this. So at that point, from this path it says, what are the folders in my file that have stuff? And cat in the box has it. Text doesn't have it, but Python is stored on everything inside.
It's because I'm running it from that level. If I were somehow down there, no, I have no idea what it is.
So if you go in, just go into the test folder, and then do Python test underscore that math.
Yeah.
It doesn't do anything because it's not. You have to actually run the function. Your test math. So let's say I have it run test underscore. If I have it run this, it should throw me an error. Anyway, yes, you're right. There's a little more complexity involved in this because of using setup.py. What setup.py does is it packages your entire application.
these are my rules to check the stuff, so in case you see it breaking, this is my thread.
There's something called, what is it called? Contract. I think it's called a contract source development. Anyways, there's this concept of a contract you can write into your like main document. So you can say like I require this. And it's things like the number is going to be in this range, and then I based on that I will do this. I specify exactly what you expect and then what you will return. Yeah, that sounds good. Yeah.
So, would you be going over this magic?
No, we were not going to cover that. If you want to ask me what that magic might be, the person to tell you about it. The setup of Python.
Sorry, also, do you mind about the break?
Oh yeah, it's pretty much break time now. Yeah, I will do that. Okay, so it's 10:15 and there are snacks and coffee outside, so we're going to take a break until about 10:30 or so. So, what? Oh yeah, you keep working if you want to, but do not miss your snack window if you want a snack. And we'll be here to answer questions.
Give me a second.
Okay, so quietening down now. Okay, so now that we've been working on adding some tests, we're going to move on to test automation. So we discussed how having tests for a project is kind of like a bare minimum standard for quality. The next bar to hit is to have those tests actually run regularly. There's nothing worse than going to a project and realizing the tests haven't been run in months and they're actually broken. In order to make sure that your tests actually work over time, you have to run them regularly. Well, a lot of things about testing kind of come down to increasing your trust and your confidence in the code that you're working with. If tests haven't been run regularly, then your trust in them is kind of eroded because you don't actually know if they work.
Yeah, so I guess I apologize up front if these slides are a bit magical. I will try and get some more documentation out afterwards as to how we set up our test automation here. So, but this was intended just to get you, to show you an example of how you might set up test automation for, let's say, an open source project. So for our open source project, Cat in the Box, which does nothing meaningful, but that's beside the point, we're making use of Travis CI. Do any of you actually run like a build server at your workplace or wherever, like Bamboo, Travis, Jenkins? Okay, great. So a lot of you, cool. So Travis CI is just, I think they have paid options, but I think they're mostly used by open source projects like on GitHub, and they let you use their servers for free. Just by adding a Travis configuration file to your repo, Travis will pick it up and it'll start running your tests, how you configure them to be run. So I won't go into that like detail how you set it up right now, but if you're curious, I'm more than happy to talk about it afterwards, and I'll try and supplement that with some documentation later on. And I forget where I am now. Yes. Yeah, so we're also making use of a service called Coveralls, which will do our coverage reporting. So I'm actually just going to click this link right here and hope it works. Great. So Coveralls is sort of like, it's like Travis, but it's for keeping track of test coverage over time. So I'm going to try and zoom in here. Great. So the reason why I like this, along with Travis, is that it lets you easily run your test suites and coverage reports against open branches or PRs against your repo on GitHub. So actually, after this, we'll be getting all of you to open up we'll be getting all to push your branches and open up a PR, and then we'll be able to see Travis and Coveralls running against your tests, right? And hopefully, coverage will increase over time, you know. But here, just a nice way to see the history of your repo and everything, and I guess how everyone's open changes are doing, you know, whether they're improving coverage or not. I should also show Travis too, sorry, very briefly. Right, so we have Travis set up for our project to run our tests against Python 2 and Python 3. So that's something you can do very easily, and just whenever you submit a change, Travis will pick it up and run the test automatically. And thankfully, our jobs had succeeded, hence the green check mark. If it did not succeed, it will be a red X. And there you go. I encourage you just to browse around this too, just to see what's out there, and we'll be getting more into using it during the next step of the tutorial, hands-on stuff.
So the builds that we've set up, so if you're setting up automated builds, you can do things besides just running your tests. Like we have our PEP8 checker that runs, and we enforce PEP8, so you can enforce all kinds of static analysis standards. It's really helpful because it saves a lot of time for the developer and for any reviewers. If you have style guides that you want enforced, but you're having your reviewers enforce them, it spends a lot of their time, which they could be spending looking for more important things. Instead, you can automate that. There's lots of existing tools, like you can use Pytest PEP8 to check for PEP8 compliance, Pytest Flakes to check for syntax errors, and it's really handy for developers to get this feedback right away. So what you'll be seeing with our project is when you submit your pull requests, you'll get feedback right away from the status of the builds. And you can find out stuff like, for example, if you're using Python 2 and you actually wrote something that wasn't compatible with Python 3, you'll find out right away. So you don't have to spend any developer's time checking into that. So the next step, oh, okay, now let's go for it. Okay, the cat is over your name, but I will do it. So the next step is to create a pull request. So with the tests that you just created, you're going to commit them to your branch, push them back to the repo, and create a pull request. If you're not familiar with GitHub or you haven't done this before, the terminology is a little bit confusing. You're basically saying that you want us to pull in your changes. That's why it's a pull request. I think a push request would have made a lot of sense, but anyways, so yeah, don't be intimidated by it, though. It's actually pretty easy. If you follow along with these steps, it should just be a couple of button clicks, and then you'll get the instant build feedback right away. If you have already done this and you're looking for something to do, you can take a look at the other pull requests and do some code review for people. Give them some feedback on the tests that they've written. Be sure, if you haven't done code review before, some important things about it: make sure that you're being respectful of the people that you're reviewing. Also, make sure that you use a positive tone. It turns out that written communication is often interpreted as being negative. Even if you don't mean to be negative, the person could read it and think you're being negative. So even try to be more positive than you might normally be, because it kind of helps out. Makes it a bit easier to take. And if you're interested, there's a really great presentation from RailsConf about implementing a strong code review culture that has some wonderful tips about good code reviews in general. But yeah, so let's create the pull request and then do some reviewing if you're out of stuff to do.
So everything that test file or test directory, all the functions are test files.
So if you type py.test.
Well, I guess that's kind of, at least that's how I understand Java. It used to be for Java. You had to prefix everything with test directory and implementation.
So this is running Pytest actually, like not the rest of the operator.
Yes, I believe this is anything that starts with test underscore.
So it knows how to say, hey, what function is that? File, module.
So it looks at all the folders in your branch code, sees if you have any folders that start with, like if you have any files that start with test underscore. And the first file inside those files, such as one that start with test underscore. That's my guess.
My guess, right? I think that's how some things use Java. So I think in other languages are more challenging because they don't expose time as well. C probably does. If you're understanding more about this, find me a binary function this way. You want to know things, all of these programs.
Yeah.
Py.test dash dash help. I think we have really big ones.
you want to go get a coffee? Just go. There is a small error in the instructions, actually. This bit that says git push origin master, you actually want to do git push origin PyCon 2016. Master is the name of the branch you want to push. So you want to push the branch you've been working on. Sorry about that.
Probably wants a comment.
Okay, so you are managing currently? So the branch are you a master?
Do you want us to be doing all of these steps on the same local branch, or do you want us to be making a new branch for each step?
Same local branch.
Okay.
Yeah.
All right.
So you can like kind of see the coverage go up over time with your one push.
She wants us to do them all on one. So you don't actually have to make this branch. Just we thought
So when I did
so
that,
instead of doing git push origin,
so I made changes, and I did
git push origin. Did you commit?
I committed, said there were no changes.
Okay, so that means you've already committed, it sounds like. So do a push.
Then I went,
Oh yeah.
and then I select that one.
Yeah. I mean, I guess this step is not necessary. This is more to illustrate the test automation. So if it doesn't work, don't worry about it. We'll get some more tests ready afterwards. This is all we're working on.
Where's the file that you mentioned?
Oh, it's okay. So we'll just come through this master. Let's see if it's on which is probably PyCon 2016. Yeah, this is like it should show if it has. It should work after that. You'll be able to go make a pull request.
What was I doing next? Type git status.
I don't know. I think people are. Maybe we can see where people are at if you want to add. See, it seems like people are slow, especially since that stat was wrong. Hey, so quick poll. Who here has managed to make a pull request? Who here has been able to go to Travis and see the build for their pull request? So you have like a check mark by your commit, hopefully? Okay, great. So I think maybe we'll do a couple more minutes of this and we'll move on to writing more tests. But in the meantime, if you want, you can look at everyone else's pull requests and maybe leave some comments, or just dig around Travis some more, coveralls, see what's up, or look ahead in the tutorial if you'd like.
Okay, so where's test cap? That's not it.
I realized before that a week ago there were a lot of changes. Yeah.
Sorry.
I merged all the changes and right now, and when I create a pull request, now I get the merged changes that I checked in as well.
Okay, so you
trying to figure out why I had an X. I don't know why coveralls decided that that coverage was like not enough, I guess.
You did add it up.
Yeah. Seems a bit harsh. You want to cover all of it.
So you can also click on operation, version operations pop up, which is also, it's handy to remember, it's alt backtick. So here it's alt and hit backtick.
I heard something.
Under the different operations. So, and then there'll be checking on your status.
I'm trying to find some examples where the actual build part failed, but I think everybody's, looks like everyone's handled that okay. I don't know why coveralls is being so picky. I would think a 1% increase was enough. I guess it thinks you should increase it even more. I don't know.
Well, it may not have status. The status is, it's not dependent on the version. So, but if you click version control, it'll show whatever your status is. So if it fails, pushing Mary.
Okay, I think we're going to get started again. So now that we have the pull request, we're going to go into some of the Pytest features. So you can use Pytest to add more tests. And as you commit and push to your branch, they'll be automatically updated in your pull request, and the automation will pick it up and run. So we're basically set up now that we can just kind of just keep adding tests from here on out. So for the next exercise, we're going to talk about something that's come up a few times in this tutorial, which is about trusting your input. You might have noticed that the test cases that you filled out for the cat years to human years were pretty trusting of the input. They're kind of just expecting you're going to pass in values that you actually would want to handle. Can you what other kinds of input can you guys think of that might not be what you want for cat years to human years? Strings. Anything else? Negative numbers? Pictures of a cat, you probably wouldn't want that. Dogs.
Maybe we'll have that in V2 of the function.
So it turns out there's all kinds of, so if you wanted to have test cases that were testing invalid input for this, there's all kinds of stuff you might want to do. Negative numbers, 0 is probably not a valid age. Fraction of a year is a valid age, but you want to make sure it works properly. You want to make sure most valid ages work. A cat is probably not older than 1,000 years, so you want to test that. Totally the wrong data type, so string or list or something else, also not a number. So we're going to introduce a new Pytest concept now. This is Pytest raises. So in some of your tests, you want to test that the code you're running actually raises the exception that you expect, and that is where you can use Pytest raises. So this slide doesn't have the nice syntax highlighting that the other ones have because I did it, and Michael did the ones with the nice highlighting. But what you can see is if you try to add the string 2 to the number 2, it raises a type error exception. But if you use this Pytest raises and you say that you expect the type error, then it continues on nicely. So this allows you to write tests which will fail if the exception is not raised.
And will also not cause your test just to quit and not run the rest of them. That's the key thing, right? You don't want to stop the execution of your test run entirely. So what we're going to do now is write some more test cases for our other module, SafeCat Math, which will actually test that the input is the kind that we expect. And if it isn't, then it's going to raise an invalid age exception. Yeah, so as Christie mentioned, we're going to do that. As part of this, I'd recommend maybe not diving directly into using pytest.raises, but maybe try actually getting your test like to raise this exception first, just to observe, like when it happens, right? So in our example, it was when it's not an integer or a float, it raises an exception. So maybe pass in a non-int or float first before you start using the Pytest features.
And if you've already gone through this exercise, I recommend if you're looking for some more activities to do because you're ahead, the step 8 is maybe a good place to look. It's all about refactoring, and maybe you would spend a bit of time there. So if you're out of stuff to do, start working backwards from the end of the steps, and we'll meet in the middle. I feel like we shouldn't spend too long on this one. Then maybe go on to the next one. It's like 10 after 11. Actually, I don't think I have anything great to recommend, unfortunately. So the naming convention that I follow, I heard about at a conference. So it was like a talk at a conference years ago. So it's basically like 10 things that just sort of piece together. I don't have any great resources, unfortunately. There's a guy named Gary Earnhardt that talks about testing a lot. He's got some really good stuff to say. Yes, yeah, exactly. Yeah, so like he's got some great stuff. Yeah, it's really about all the like. He usually talks at PyCon too. I don't think he's doing this year though.
Great.
It's really hard because like people are constantly typing and stuff too when you're talking. It's a bit just waiting. Yeah, go ahead. Sure. Yeah. Go. You do it. It's your idea. Okay. I hope the microphone isn't actually picking this up. It'd be very funny. Yeah, exactly. Yeah.
Hey, so just to get a feel of how everyone's doing here. So has anyone not been able to get the safe cat math conversion function to raise an exception? So like with invalid input? Okay, great. Good. Who here has not been able to try out pytest.raises? Okay, cool. So maybe a couple more minutes and we'll move on to the next step of the presentation or the tutorial.
Fixtures. You. Fixtures or something. Yeah, that was pretty good. I feel like that part has been smoothed out quite a bit, but it still could be better.
Oh, sure. There you go. I can just write it up too. Some syntax highlighting. I guess one thing I should mention too is who here does not know what the width does in Python, like what it is? Okay, so I can talk briefly about what width is, just so you know. So width is how you invoke. It's called a context manager in Python, and a context manager is basically like a fancy try except. So when you enter the context, it runs some setup, and when you leave the context, it does some teardown. So like entering is anything inside the indentation below the width, and teardown is when you get out of that indentation block, if that makes sense. So in this case, Pytest will only accept this particular exception while you're inside of that code block. And you can use these for other things as well, which I won't get into now, but if you want to talk about that after. Yeah, so okay. So the question was what's the protocol for the context manager, basically? So it looks for like double underscore enter and double underscore exit, I believe. And it just calls those when you enter into the context and when you exit. And the key thing is that even when it raises an exception, it will always try and call the teardown. So if you have to like clean up after your code raises an exception inside the block, you can do it like that.
And the exception is passed with the exit.
Probably, but it is. Okay, cool, yeah. I guess it would have to be so you can
It
clean
is
up.
passed with the
Yeah.
exit, so you can do, that's how they do it, they
Ah,
pass
yeah,
the
true.
exception at the exit.
And just assert that it was raised, yeah. Cool.
I had a throw it something like what's the other? Usually it's not the fact that we trying to make sure that the function whatever is in the function, make sure that you import the function or import the module or import the similarly in Python, everything is full stack object. Includes exceptions. So you got to so if you're importing, so if you see where is this evaluation, copy the search path. So it's
Okay, so hopefully everyone's had a chance to try out raises. It's pretty handy. So next we're going to go into another Pytest feature. So this is Pytest Fixtures. So on the off chance that someone knows, who here knows what a fixture is in the context of Pytest already? Okay, cool. So this is good. This is brand new stuff for the most part. Great. So normally when you have like a test, you generally have some setup you have to do before the test and some teardown, right? So coming from like the standard unit test style of test that comes with Python, you have a setup method on your test case class that gets invoked before your test. And there's also a teardown method that gets run afterwards. The Pytest style of test does not have that. Instead, we use fixtures. And a fixture is just a nice, concise way of doing the same thing, setup and teardown. But also, it allows a way for you to pass the thing that you've set up to your test sort of dynamically. So in this example here, I have a Pytest fixture, and this is sort of, or this is declared rather by using the Pytest.fixture decorator. Who here does not know what a decorator is? Great, perfect. Okay, cool. So I can just summarize it too. A decorator is just a wrapper for a function, right? It adds some extra functionality onto whatever it's wrapping. So in this case, it just tells Pytest that this thing is a fixture. And Pytest does some magic here, which I guess I'll try to describe. So we have our fixture, which is cool stuff, and the thing it returns is an instance of this cool stuff class. And down here we have a test which uses the fixture, and I'll explain the magic in a second. But the main thing is, no, sorry, I'll do the magic now, so it makes sense. So what Pytest will do automatically in the background is map the name of your fixture function to the arguments inside your test, right? So notice how cool stuff is the same in both places. So it will do all that glue for you. And so that if we assume that cool stuff has a isCool attribute, as we do in our test, you know, this thing should work. So fixtures are a good way to do setup and teardown, as well as they're a good way to ensure that your tests are always interacting with like a new thing. So in this example, our fixture is a list. Now we know that we can modify lists, right? So what happens if we modify this fixture, this list, as part of one test, and then the same fixture gets passed to a second test that doesn't know that it was modified, right? So we sort of have this dependency now between these two tests. When ideally what you want is a fresh list or a fresh fixture for your test. So with a Pytest fixture, with some other magic which I'll get into later, you can actually configure it to give a fresh fixture for each of your tests that require that fixture, right? So in this case, even though in each one I'm deleting a different element, it is not the same list that will be passed to both of them when they run. It will be getting the fresh list each time. And we can expand on that, you know, to have it maybe instead return like your application, you know, like another class with some complicated states that gets changed over the course of like the methods on the class or whatever. And it's a good way to control, or rather to stop the dependency between tests, right? Because each test should be able to run in isolation without depending on any other test to have run beforehand. And also, you should not influence the outcomes of other tests by what you do in any of your other tests. Great, so in this next step, we're going to actually use fixtures. I think this is the coolest part myself, because it's part magical, but also just really easy to do compared to other styles of setup and teardown. So this is step 5, and yep, have at it. If you finish early, I think there is a bonus one for this. There should be. If not, again, we encourage you to look at the other pull requests of other people, leave some feedback. Or also, Pytest has a lot of fixtures built into it, which I guess I alluded to over here, link at the bottom there. So if you want, you can go have a look there too. We'll talk a bit more about the other fixtures that are built in later on, but if you want to get started on that, if you finish early.
Oh yeah, one thing I'm not sure if we mentioned yet, if you get stuck at all of the solutions or a solution for all of the problems are in a branch called solutions. I think most of the READMEs link to it, but this one does at least. So you can actually like take a look at the answers. So if you get stuck or you're just looking for some inspiration, you can look over there.
Okay, it makes it to be that it's enforcing. I'll see if I can get to this page. What is your username? Just like a direct request. Okay, cool. So I'll have a look and I'll try and watch you. Oh, there you go. So in the bottom there. Okay. So I'm defining Pytest. When you want to test locally, actually, what command do you use? Test, okay. It's weird. It's supposed to also run this check too. But in this case, looks like it is some syntax checking, and the name Pytest was never defined. So maybe I guess an import from Pytest.
You gotta erase the commentary.
Oh yeah, we did that so perfectly.
Michael, I can't remember the key combination to switch back to the other tab. I don't know what's wrong with me right now.
Numbers. Is there anyone having issues using pytest.fixture to create a fixture? Great. Oh. Okay, I'll be over in a second.
Oh yeah, so you want to put that on top of the fixture function that we created. So like if you go back to the so fixture has a fixture at the top of this function, and we have a separate thing which is a test, which references that server. So it can stay in this file for sure. It just has to be on top of the fixture function. So I think in the step, I believe this one's using a fixture that returns an instance of a category class. So if you run your tests, currently in every test, our first line is C is category, right? But you notice how it's repeated. So we can refactor that by having a fixture. So you can make a new function and call it, I think, examples category client. Yeah, and ignore it, it's great. And all it does is it returns an instance of the category. Yeah, and it's a category class. Yeah, exactly. So this is like a very simple example, but this can actually scale, like I said, other applications. Great. So now you have to update your test to actually reference that. I guess one of the changes you'll have to change the C's to the category clients, but that's required.
Right, that's what I did.
Yes. And then if you try running it right now, it should work. Great. Oh yeah. Oh yes. So this is because what actually gets inserted here on the PyTest is the result of calling this function. Oh, yeah. It's all magical. Yeah. Yep. But it's I think this gets really useful magic.
Oh, the user just
Yeah.
I have one here below.
Okay.
We're still testing. Okay, so what's the well,
What's the project console?
this file is not big compared to the one.
Oh, sure. That rebase we did before should have also had a
This is mine here.
oh yeah, so
Looking at this spreadsheet,
yeah.
it's like, I don't have that many tests.
Yes. So this is also done test file, right?
So the parameters
For category,
apply.
yeah. So the test files, yeah, there's more stuff in solution to those. But you were talking about
Specify
the category class
what
itself.
Dot,
parameters you
what
want
is
to
the
set.
dot dot dot?
Yes, to the function.
That is
So
Western
it's
stuff,
returning
whatever you
function.
want to type. That.
So
All right,
Oh,
well,
yeah.
what I want to type.
Yeah, that's
Like,
part of
what do you want to
pretty clear in stuff, so I just
I don't know, this is the first time I've seen a picture.
Um,
And that's it, not, no, so if you look at your code, look at the code that
So
they
if
give
you
you.
go
Okay,
here,
so these are valid checks, they're actually. Oh, I see. So,
that's common across all.
here, if you notice,
So
every single time you
those
run the
types of
test, they go
pictures, we
C
factor that out
slash data catch.
with ones, right? And
So
when you
it's
do
going
all
to
the
be
time,
Part of the problem is that category example is not.
yeah, so based on
So,
here,
It depends on
that
what
would
you're
give you
doing,
an
and a
example
lot of
of
you
cases
see
are
guys
a
the
bit more
picture?
complex
and then
than
put that as a
the
magic.
more fixtures. It's definitely useful in unit tests.
Cool.
But if you're writing
see,
like
and
system
then,
tests,
so I'm trying to look at
So it's like,
tears it down at the end.
they
And
all,
passes it
well,
right again.
no, great, okay, I thought you said they
So
all-
like this
they
is
don't
a
all-
lot great, it is probably easy, like that's
And-
exactly the same thing. But if there's anything you have to do, also like if you want to.
Okay, we're like, as long as they have a common, just like basic SQL, cat, parameters, and cat, categories, so I see this examples of that.
You want that to happen with all your tests, you don't want
I don't know offhand how to fix this. There's an extension in Pytest for block output, but I don't think that's actually a button. I feel like there's probably a flag you can pass in Pytest that will, like, revoke or something like that.
Oh, no, right, so I can use that this is a method to fix all the
What's that?
This is the name of the function, but here, it's obviously the object of the function.
That might work. So, were you running with the setup by?
It worked, I mean, the structure was.
Yeah, so I don't actually have a good answer for you, unfortunately.
Okay.
Yeah, it's partly our fault too for fixing that. But also.
So who's still working on adding fixtures? One, two, a few people? Okay, we'll do a few more minutes and then we're gonna move on to the next. Actually, we've only got 15 minutes left, so maybe we're just let's just move on now, I think. And you can always work on this stuff outside of the class as well, and if you submit pull requests, then we may notice and give you some comments. You can send questions to us if you run into any trouble.
Yeah, we're definitely more than happy to talk about these things outside of class too. Twitter, email, whatever.
Okay, so what we're going to talk about now is something called mocking. Who knows what mocking is? Not that kind of mocking. So a few people. Okay, so this is a very powerful thing in unit testing. You might find that actually. So I'm thinking we could just go through all the content and then people can work through the exercises.
That's a good idea.
Yeah. Okay. So we're gonna breeze through all of the content now, and then with the rest of the class, you can work through the exercises at whatever pace you'd like. Okay. So mocking. So you might think that this is great. But I work on code that does things that actually interact with the outside world, like making HTTP requests to web servers, using time, using random. So how do I write unit tests for that kind of stuff? So it turns out that this is really easy to do in Python. So you do this by creating something called a mock object. So this is an object that behaves like the one that you're calling, but you can control it so it can do exactly what you want. So you can, if you're calling a time function like time.sleep, you can use a mock object instead, so the sleep doesn't actually happen, but you can look at your object and make sure it was called in the way that you expected it to. You can use it for like mocking out the requests library, for example. So instead of making an actual HTTP request, you actually call into your mock object and you can return whatever value you want. And you can use this. So you can use this to stop your unit test from doing costly operations like sleeping. You can use it to make sure that the functions are being called in the way that they should be, and you can make sure that everything is actually plugged in together correctly. It's important to note, though, that you probably want to have some kind of test that actually does exercise the functionality, like a system test on top of this, because if all you do is test, let's say you're writing something that integrates with Facebook and like calls into a Facebook API, and you never actually try it with the Facebook API, you're probably going to run into trouble. So it'd be good to supplement this with a few system tests, which we don't cover here. So in Python, the library that you'd use to do this is called mock. You can install it with pip. If you're using Python 3, it's actually part of the standard library now, so you get it for free. So what you can do is you use this magic mock object, and you can basically do anything you want to the object. So you can treat it like a list if you want to. You can call a method on it that doesn't exist. But you can see, like, I call foo, and then I can check it. The magic mock object adds a bunch of attributes that are really useful, like the number of times that the function's been called, what arguments it's been called with, that kind of stuff. So in true, this is another one of my slides. At least this one has syntax highlighting. So for example, let's say that we are using our mock object and we call our imaginary method bar with the value 6. We can use the assert called with method to make sure that to assert that our function was called with 6. And you can see if we assert that it was called with 7, we get an exception because we expected a certain call and it wasn't made. Another thing that goes hand in hand with this is patching. So basically with Python, you can like reach into the libraries and you can replace anything with anything at any time. So you can take time.time and you can replace it with 5 or whatever you want. But that can cause problems if you don't clean it up properly, because anything else that uses that is going to get whatever value you replaced it with. So patching is something that automatically will set these mocks up for you and then clean them up when you're done with them. so they don't cause weird side effects. Pytest makes this really easy with a plugin called mock. So we were talking about fixtures. This mocker is a fixture that allows you to set up mock objects, and then you can do things like calling patch. So you can, in this case, we're controlling time by saying the time is always 7. So in our test, we're calling our time message function, which calls time.time, but we patched it before we called it and made it always return 7. So the value that it returns when we called it says the time is 7. What? Oh yeah, and well, did I have an example for that? Oh yeah, and that's really helpful for randomness as well, which is something that's very hard to test for. So you can patch random.randint or whatever you want.
Yeah, since the goal with your tests is to like always be testing us the same thing each time they're run. So if your function returns a random number, you know, like it's sort of hard to make sure that like it actually works. So you want to control the amount of, you know, like randomness you have in your system, like time or random, as Christie said.
Another important thing to note, and I think I even actually forgot to do this in some of the examples, if you're using mock objects at all, always set this autospec equals true when you're patching. This will make sure that the interface is actually being called correctly. So if you're patching one of your own objects and you do something like changing the arguments it's called with or changing the attributes, and this will actually raise an exception if you use the object incorrectly. Otherwise, the mock object will just let you do anything that you want, and then you won't know that things are actually plugged in together correctly. So the next exercise is all about using mock to control time, but we're going to skip to the next set of content.
Yes. So we saw fixtures. Another thing we can do, oh, sorry, it's not, I'm getting ahead of myself. So we saw that in some cases, our test, like we have a lot of test cases and all they're really doing is testing different sets of inputs with different sets of outputs, right? I know that someone else that went ahead already got to this point. But we can, Pytest has a thing called parameterization, which lets you sort of specify what inputs Pytest should pass the test, and then you just write a generic test which does something. So in this case, for example, we are testing the bad input that causes safe cat math thought, cat years to human years to raise an exception, right? So we mentioned things like it's a string, it's a list, not a number, et cetera. Currently, we have like 5 different test cases for this, but this could be one test case that just tests when it raises an exception. So here we have, this is how we do this in Pytest. Use another built-in Pytest decorator, pytest.mark.parameterize, and the first argument of this is the argument of your test function that Pytest should put these values into, right? So it can differentiate between fixtures and parameters. So in this case, see the age string at the top corresponds to age in the function spec. And when Pytest goes to run this test, it'll actually run this test 6 times, 1 for each of these sets of input. So you can also do this for fixtures too. So our fixture example was with the category client. Suppose that you had a fixture which returned something which you can use to talk to your DB. Maybe you want to test different types of DB backends like SQLite, MySQL, Postgres, et cetera. So you can have one fixture which all your tests use, like so that conforms to the same interface, the thing it returns. But as part of your test running, you actually generate different types of the same fixture. So in our example here, this fixture DB creates a database connector, and we specify that there are 2 parameters for this fixture. One is a SQLite connection string, one is MySQL. And what Pytest will do is, when it goes to run this test, it sees that, oh, there's a fixture called DB. And again, it's like, oh, this DB fixture actually has 2 possible ways you can create the DB fixture. So Pytest will actually run this test twice. And as you add more and more arguments to your Pytest test functions, it will run it more and more times. So like if I combine this with the previous example with the age, it will run it a total of 12 times. So for each of those valid ages, if we add the DB fixture as well, it'll also run those again for each of the possible ways you could create DB. So it's a very powerful way to make generic tests, which test like the semantic functionality, and you sort of hide away this like the difference in like the test setup or environment through parameters. So this next step would have been trying that stuff out. So I definitely encourage you to try and get to this at some point, because it is very cool stuff.
All right, so our last section is all about unit testability and well-factored code. So a lot of us don't have the advantage of working with brand new code. So we're not like writing all of the functions and writing the unit tests from scratch. We have to deal with a lot of legacy code. So you might get back to work and look at the code you have to work with and be like, I have no idea how I would write a unit test for this. So it turns out that usually if you're finding that something is very hard to write a test for, it usually indicates that there's a problem with the code or something that could be improved on, like that the code itself actually isn't very well factored. So refactoring your code so that you can write unit tests for it actually usually leads to higher quality code. So this is kind of a contrived example, but let's say we have this function setup cats and we want to write some unit tests for it. So what the function is doing is it's for whatever number of cats we've requested, it's creating a cat that has a random name, and then it's putting them in the list, and then it's feeding the cats a random food. So if we wanted to write a unit test for this, what we end up doing is we have to use that mock functionality we talked about earlier to mock random.choice. And then we have to create this kind of like complicated and confusing thing here where we want to return all the cat names, and then we want to return all the foods because we happen to know that we're going to call random.choice for cat names, and then we're going to call it for foods. So this part is already kind of confusing for someone who has to maintain this test. And then we go through and we make sure that the results are correct. This isn't probably the worst example of this. It would get much more complicated when you're dealing with actual like legacy production code. But it basically, if you write tests like this, they end up being these complicated webs of mock objects that are really hard to write. They're really hard to read. They're almost impossible to maintain, so nobody wants to add anything to them. And then if you want to add more test cases, like if I want to test a slightly different case, I end up having to copy and paste like this exact thing pretty much and just change a couple things. So the tests themselves are basically just becoming a maintenance burden, and they're not adding very much. Oh, this is supposed to be you. Do you want to do the nice code?
Sure.
Okay. Oh, I'll have to explain the complecting, though, because that's a weird thing. So, so code that is really well factored has a few properties. This is something that you probably have your own personal opinions about. The company you work for probably has its own personal opinions. But there are a few things that I think will probably hold true. One thing is that you want to avoid this term is not a real word, complecting. I highly recommend this presentation by Rich Hickey. If you don't know who Rich Hickey is, he is amazing. His presentations are all amazing. They're very confusing, though. He talks about things like music and like sort of weaves it into software development. Anyways, this particular presentation is great. He talks about the difference between something being easy and something being simple. And he uses this term complecting to refer to code that's like all tightly woven together. It's really hard to understand because it's so complected, is what he calls it. So code that's really well factored will be uncomplected. Watch the presentation for more of that. It'll be highly cohesive, so each thing will do one thing, and it'll be loosely coupled. And if you write code that's like that, it usually ends up being really easy to unit test.
Okay, so this is an example of how we might refactor the previous set of cats test and also the method itself. So before we had one set of cats, it did everything, right? It created the cat and it gave it a random food. Now, after refactoring it, now we have broken it up into these three separate functions, right? So now setup cats, it conforms to the same interface, but we refactored it where it calls out to get the cat when it needs it, and then also to get the food. So now, when we actually go to write our tests, we actually can test these things, well, first of all, separately, right? They're all separate units that we can test. And notice how everything's just nice and it's all just nice and short, And we don't have to know about, like previously, we had to know that you called random.choice 6 times, so we had to prepare for that. Now we just have to know that in each case, it calls it once in this case, it looks like. And it allows our test to be a lot more clean, a lot more readable, and people actually want to, well, hopefully they would want to keep maintaining these.
So the last step in the tutorial, so basically steps 6, 7, and 8, feel free to do them on your own. They have some really cool stuff. So the idea with this one was to take some code that's not very well factored and try to write unit tests for it and see how you might refactor it. And then there's a solution on the solutions branch, and you can take a look at how we refactored the cat generator and its test to make it more testable. And it's kind of interesting, though, because you might not like some of the things that you see, and you might not like some of the ways that it's refactored. So it's kind of an interesting exercise to take a look and see, like, what did you think worked really well? Did some parts get better? Did some parts get worse? Did we lose anything in the refactoring? The refactored version, I believe, has a lot more code, so that's one thing that you might view as a downside. So it's basically just a balance that you want to strike as you're working on this kind of stuff. So in summary, as we mentioned before, unit tests are not about finding bugs in your code. They're about giving you more trust and more confidence that the stuff you're writing is doing what you expect it to do. And yeah, that's it. So I think we're pretty much done now. So if you want to stick around for a few minutes, if you have any questions for us, feel free. Otherwise, available on Twitter. Yes?
Who did the artwork?
I did the artwork.
Yeah.
Yeah, thanks. I hope you enjoyed all the cats. We also have cat shirts, the theme. Cool. Well, thanks everyone for coming. You guys were great. I hope you got something out of it. I really appreciate your enthusiasm early on a Sunday morning. Yeah, thanks very much.
Yeah, thank you. Remember that you can email us, tweet us, whatever. We'll be happy to answer any questions outside of this.